In our today's video, we will see about the inductance of an inductor. Imagine you have a simple coil of wire, nothing fancy, just copper wrapped in loops. Now here is the strange thing. The moment you try to change the current flowing through it, the coil pushes back. It generates its own voltage to resist that change. What is an inductance? Let's forget equations and understand it intuitively. Imagine you have moving electric charge. When they move through a wire, something interesting happens. They create a magnetic field around the wire. If we wind that wire into a coil, those magnetic fields add up and become strong. Changing the current changes the magnetic field. Changing the magnetic field creates a voltage. That resistance to change is what we call inductance. Now let's put it all together. So the equation for voltage across an inductor will be voltage equals to inductance times the rate of change of current. But from our equation, what is L actually? Is it just a number, or does it say anything about the inductor? Inductance measures how much magnetic field you can create per unit current. For example, let's say we have an inductor with an inductance of 100 millihenry. What does the 100 millihenry means? 100 millihenry means if you try to change the current through the inductor by 1 ampere per second, the inductor will generate 0.1 volts to oppose that change. So the 100 is not just a number, it tells you how stubborn the inductor is, how much magnetic field you get for a given current. For example, if we looked at an inductance of solenoid, the inductance is expressed as this. From our inductance equation, the n square term refers to number of turns of the inductor. For example, if we take two inductors, one with 9 turns and the other with 15 turns, the inductor with 15 turns will have more inductance and bigger magnetic field than the other. The second term in our equation is the area of the inductor. The bigger the inductor, the higher its inductance value, and the larger the magnetic field. The third term is the length of the inductor. When the inductor gets longer, the magnetic field is spread out over a larger distance, and the field becomes weaker per unit length. Our last term is permittivity. It tells you how easily a material allows magnetic field to form. For example, air has low permittivity, so the magnetic fields are weak. And iron has high permittivity, so the magnetic field concentrates strongly. So same coil, same current, but different core material can give different inductance value. This is it for today. See you in the next one.